Okay guys, so in this video I'm going to show you a little bit of a very short introduction into TypeScript, why I think TypeScript is such a useful tool, and also a common issue that I see that I think that TypeScript can't really help us with solving, or rather we can use TypeScript to a certain point, but there is this magical little connection point where we need to do a little bit more validation and a little bit of thinking. So let's get into it. So first and foremost, I absolutely love TypeScript. It's a great way to enhance a code base written in JavaScript. And if you are making something more serious, if you're trying to build an application that is going to work at larger scale or for a company or something like that, I think that this is a really great tool to use to kind of mitigate some of the issues that comes with maintaining a big system in a loosely typed language like JavaScript over time. But let's just talk about the basic setup first and foremost. So this application that I have here is super trivial. All it is a little, where I'm just serving up a static index, like a static HTML file basically, and logging out some information to the console. And in order to do this, we have a few things. So we have our Webpack configuration that just uses the TypeScript loader in order to just read in our main.ts file, which is this file here. We'll talk about all of this in just a moment. So this is our entire application. So we're importing the user model, we're getting the user, etc., etc., and then we're just logging out the user, right? And here's our little server, which is just a Express server that's over here, where we're just improving, we're grabbing Express and our types and instantiating our application, serving up the stat content from our public directory, and then we, as you can see, we were just serving up that static file. And there's one endpoint to grab the user. We'll talk about all of this in just a moment. And here's our HTML file. That's it. So, first and foremost, let's talk about the typing system. So what we've done here is that we have a user endpoint where we want to be able to just grab a user, and that's pretty easy when you're using TypeScript. So what we have done here is that we've declared, okay, so a user has a name. Let's look at the name type. So a name is just a type alias for an object that has a first name and a last name, which both are strings. Actually, these should be string, like that. Anywho, so then we have a function that is just a convenience function that takes in two strings and returns that said object. So when we're in our application here, you can see that we can actually now type this object structure to a name, and that's our type. Now we have a semantic way of expressing what a user's name is in the system, which is awesome. Like, now we can trust that the semantics of a name is going to stay the same, and we can use this type instead of just a flat, like a just plain old JavaScript object. The same thing goes for an email address. So we have an email address, which is just a type alias on top of string to be able to name it an email address. And then I have this little function here that takes in a string, does a basic validation on top of that string to make sure that it follows some type of convention, because an email is not just any string, it has some semantics with it, and if it's not, it just throws an error, and that's basically it. And then finally we have the user, and the user is just a class that has two fields, a name and an email, and it has a constructor, and we will talk about this function in just a moment. So what we now do is that we've instantiated all the way up into the user, and as we can see here, the Visual Studio Code is helping us saying that, okay, so user, this user is a type user, and then we send the response to the client, which is here. So what's happening now is that, all right, we're going to the network, we're grabbing the response, we're parsing the response into a promise. We are just, and that's going to be a user basically. So if a type user, and then we log out the user. So we can actually reuse this model that we have on the server on both the client and the server. Like that, and that's pretty great to be able to have that connection right. Now, what's the problem with this? Well, the problem here is that if we really examine this, let's just think about what this means. So what we're saying here is that the network is grabbing the user from the user endpoint, and then we are typing that as a user, and then we're continuing the execution of our program. But is this really true? Well, no. Let's look at this. If I do this, what just happened? Well, what just happened is that the response from the server on our user endpoint just changed. This is no longer a user. But we stated here that we're expecting a user. So if I now go and refresh this, boom. As you can see, the connection is lost. The type means absolutely nothing, because what's actually happening is that the response is actually the JSON function on our response is just returning a promise of any, because we cannot know what is coming over the wire. The network can send anything. There's no way for us from our client-side application to know that what's going to come over the wire. Anything can change, and trust me, this happens all the time. You're working on different features and people forget all the time that if you update the model on the server, the front end needs to know about it. Because if the client side doesn't get something that it's not expecting, it's going to break. And this is why I argue to people that in order for TypeScript is great for when you are certain, like when you start the code on the server, and when the client knows for a fact what it has on its side of things. But the connection between the client and the server, the actual network call, that's something that you need to validate. And TypeScript will not help you with this. So what I like to do is to do something like this. So let's be honest here. Let's call this an any, because it is an any. And let's just call that JSON, because we don't know what it is. And then let's do this. We'll look at this in just a moment, because now we are being honest here. We're saying that, oh, actually, let's do this. Because even in Visual Studio Code, you can see here, like I have typed this to be something that I expect to be a user, but it's not a user. So if I do what I should be doing, which is to make this into an any, now you see that the inferred type is user any. Now all of this is gone. So this is now any, because as I said, TypeScript doesn't know what a user actually is. I just said that it's a user, but I don't know either. It could be anything. So let's do that. And let's do this. And then finally, let's do that. So now let's try to refresh this again. So here we have something that is okay. It's called type checker, and it's logging out some information, and there's even an error here. So let's go through that for a moment. So user.from. Now what is this? Well, what I like to do is that I like to declare a parser or a function of some sort that is responsible, or at least a step that is responsible for taking the response from the server on my client and parsing that into the model that I expect to be using for the rest of the execution of the program. Think of it as serializing on the server in typed language, where the request or the network call contains some information that is going to be expected to be in a certain shape. And then it is the responsibility of you as the programmer to assert that the shape of the data that you are getting is in the correct format before you continue with your program. So this is what I'm doing here. So I'm getting in JSON, which could be anything, and then I default that to an object. I know that I should expect there to be a name, or it could be a name, it could not be a name, it could be something anyway. And so I just guard myself, and then I have this little magic function. We'll talk about that in just a moment. Now this function could be much nicer, but it's just for demo purposes, where I have a type checker that takes a string, because I expect, like this in the signature here, is that I expect the type to be a string. In other words, the thing that I'm going to grab is going to be a string. And then I give it a default value. In this case, it's going to be an empty string, and then the field name. So if the field is actually missing, or like the field that I'm trying to access is the first name, right? And then I basically get a function back that is going to grab this value. And that's all there is to it. And then I go through like all of the properties that I want to get on my JSON object here, and then I do the same instantiation as we saw on the server, and I return a user. Now, The reason why I do this is because now I can actually declare my own typing system with some reasonable defaults, and I can actually also express that I want to be able to log out that there's a field missing. Now this is very useful because the thing is that I want to be able to, like in an effective way, know what properties were missing, because now when I'm looking in my console, when I'm debugging this, I can actually see that, okay, the first name was missing, the last name was missing, the email address is missing. Now I have something to go on. Now I know that it doesn't matter where my program breaks, because I know that at the start of the program, which was when the network call was made, I know that I got something back that I wasn't expecting. So that can actually, like, and you can even see that the error we saw here is kind of tying into what I was saying earlier, that the email address is we try to instantiate it, but this code is now failing. So that's pretty useful. But what's also kind of interesting is that if I did this, email address foo@bar.sc, and then we refresh that, and then we refresh again, now the program will keep on running. Like, even if there's a partial mismatch, like the only reason the code broke was because I actually wanted it to break because the email wasn't provided. But if the email is there, the program just keeps on running because I am providing default values to my implementation. So because I have these default values, I can actually continue the execution of the program and still be alarmed that something didn't work with the network call. That's going to be more robust and safer than just failing, because in today's web applications, throwing an error can actually result in the entire application breaking. So the type checker, as we saw earlier here, I'm not going to dive too much into that. I have another video where I kind of explain the idea behind it, but in essence what it does is, as I said, all it does is that it validates the different properties on the input, returns a function that expects that type of input, and then just does some validation and returns the value. So what I want you to take away from this is that even though you are using TypeScript, it's great if you can trust that the data that you are getting is actually in the shape that you want. So what I want you to remember is that everything on both sides is going to be safe. So when you have code on the client and you're sure that you have the right data, the type is going to be safe from that point on using TypeScript. The same thing goes for the server. But when you are actually instantiating your model, in other words, when you're actually getting the data from, say, a network or a database or something like that, a database is a little bit more secure in general, but those connection points, well, you cannot trust that your type system, or in this case TypeScript, is going to tell you the truth, because you have to check. Because to be frank, you don't know what's coming over the network. So if you validate it and make sure that you're getting the correct thing, then you can use the type system from then on. But always remember that never ever trust what's coming over the network, not on the server and not on the client. Have a great day.